In this video we will look at compound inequalities, and the first one we'll look at is OR. So first thing we need to do, solve each inequality for x. So we have negative 8x less than or equal to 15 minus 4 is 11, and then we're going to divide by negative 8. And we have x, and when we divide by negative it flips my symbol over, so I have greater than or equal to negative 11 over 8. And I'm going to make that a mixed number so I can graph it. 8 goes into 11 one time, and 11 is 3 more than 8, so I have negative 1 3/8. Let's go ahead and graph that quickly. So 0, and we have negative 1, negative 2, negative 1, negative 2, and negative 1 3/8 is about halfway. It says equal to, so it includes that point. And x is greater, so that means that x gets bigger, so we're going to have to go bigger on the number line. So that's our first graph. Let's go ahead and solve the second. Minus 34, minus 34, and we have 12x less than or equal to negative 37. Divide each side by 12, and x is less than or equal to negative 37 over 12. Since we didn't divide by a negative, the symbol stays the same. And again, let's write that as a mixed number. 12 goes into 37 3 times. We have negative 3. 3 times 12 is 36. 37 is 1 more than 12. And so let's go ahead. S is less than or equal to negative 3. So let's go down to 4. So negative 1, 2, 3. It is equal, so I have this closed dot right here. And x is a less than, so that little point right here means it gets smaller, so I'm going to go ahead and go this way. So I have OR. So here's my inequality. So x can be greater, so it can be over here on this side, any number, or it can be over here on this negative side. Either one will make it true because it is an OR. Let's take a look at the AND. Go ahead and solve each inequality for x, so subtract 29 from both sides. 5x is greater than or equal to 25, and then we're going to divide by 5. And x is greater than or equal to 5. So let's go ahead and graph that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 5, so we're going to start there, and it says equal to 5, so I can go ahead and put a closed dot because it includes 5. And on this side, we have the greater than inequality. So the big side of the inequality is with the x, so that means the numbers get bigger, they get greater than 5. Now we'll go ahead and solve the second inequality. So minus 12 from both sides. Negative 3x is less than negative 27. And I'm going to go ahead and divide by negative 3. When I divide by a negative, it flips the symbol. So I have x is greater than. Negative divided by negative is a positive. 27 divided by 3 is 9. So let's go ahead and graph that. So here at 9, it is not equal to, so that is an open dot. But we are on the bigger side of the inequality, so that means that it gets bigger this way. In order to be AND, it has to be true for both. So if I pick the value 5, 5 isn't up here above the 9. So our inequality is going to be x greater than 9 to satisfy both. Let's look at another type of AND. So we're going to go ahead and do the same thing as we did before. Get x by itself, so negative 11x is less than or equal to 37 plus 7 is 44. Divide by negative 11. We have x, and the negative flips the symbol, so we have greater than or equal to 44 divided by negative 11 is negative 4. So let's go ahead and graph 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is negative 5. This is 5. So we have negative 4, and it's equal to, and x is greater, so x is going to go this direction. Let's go ahead and solve the next one. Minus 50, negative 6x is greater than negative 50 plus 2 is negative 48. Then we're going to divide by negative 6. We have x, and the negative flips the symbol. So we go to less than. Negative divided by negative is a positive. 48 divided by 6 is 8. And we have an and. Let's go ahead and graph that. X is less than 8. So let's add on a few more here. 5, 6, 7, 8. And it is less than, so it is an open dot. And less than goes this way. If we have an and, that means I can't really have these values and I can't really have these values if it's and, right? So that means everything has to be between this negative 5, or this negative 4 value, and this 8 value. So we're going to rewrite this. We're going to kind of flip these around. So x has to be smaller than 8, but it also has to be bigger than negative 4. So instead of writing these two inequalities with an and, I can go ahead and say x is between 8 and negative 4.